Alright, so this is going to be an example in which we try to determine the rate law of a chemical reaction that has two reactants, A and B. So recall that in order to express the rate law, in general what we do is we say that the rate equals the concentration of A raised to a power, M, times the concentration of B raised to another power, we'll call that N, and of course this is also multiplied by the rate constant K. So what it comes down to is we have to determine M and N for this reaction in order to determine the rate law. So one tip that we need to know is that in order to determine the rate law, we need to determine the order of each reactant separately. So let's first turn our attention to A. So we want to find the order of the reaction in A. So to do this, we're going to choose two experiments in which the concentration of A changes and the concentration of B is constant. So here we have a table of concentrations of A, concentrations of B, and the initial rate. So in the first row, we have a concentration of 5 molar for A, and the concentration of B is 10 molar, and the initial rate is molar per second. So each of these rows represents a single experiment where they measure the concentration and the initial rate of the reaction. So again, we want to determine the order with respect to A. So we're going to choose two experiments where the concentration of A changes and the concentration of B does not change. So could we choose the first two rows? The answer is no, we couldn't, because the concentration of A does not change. It stays fixed at 5. What about the second two rows, though? Does the concentration of A change? Yes, it does. We have 5 molar here, and then 10 molar over here. Perfect. But wait, we have to figure out whether or not the concentration of B is constant. And of course, the concentration of B is constant. It stays fixed at 20 molar. So I'm going to choose these two rows to determine the order of the reaction with respect to A. So recall that the concentration of A is changing and the concentration of B is remaining constant. So what we want to do is we want to compare the concentration of A, how that changes, and we also want to compare how the initial rate changes. So what I'm going to do is I'm just going to cover up these two concentrations of B because they don't really matter right now. They're constant. So how does the concentration of A change from the second row to the third row? It looks like if you multiply 5 by 2, you'll get 10. 5 times 2 is 10. But how does the initial rate change, though? Does it change at all? No, it doesn't. It's just constant, or times 1. So what have we gathered from this? It looks to me like no matter what our concentration of A is, our initial rate is going to be the same no matter what. So in other words, the rate is independent of the concentration of A. And the way that we say this is that the reaction is zero order in A. So we just determine the order with respect to A. Now let's turn our attention to the order with respect to B. To determine the order of the reaction in B, we're going to choose two experiments in which the concentration of B changes and the concentration of A is now constant. So we just flip-flopped it. Whatever we did for A just now, we're going to do the same thing for B. So let's pick two experiments where the concentration of B changes and the concentration of A is constant. Did the first two rows work? Yes, they do. The concentration of B changes, it doubles from 10 to 20, and the concentration of A is constant and it stays fixed at 5. So I'm going to pick these two rows now to determine the order with respect to B. So the concentration of A is fixed at 5, so we don't really need to worry about that, so I'll just cover these up. So what we need to do is we need to compare the concentration of B, how does that change, and the rate, how does that change? Well, from the first row to the second row, it looks like if we multiply 10 by 2, we'll get 20. So the concentration, in essence, doubles from this reaction to this one. And how does the rate change? Well, the rate also doubles. So when we double the concentration of B, if the concentration of A is kept constant, if we double the concentration of B, the rate will double as well. So that means that the initial rate is directly proportional to the concentration of B. And if the rate is directly proportional to the concentration of B, we say that the reaction is first order in B. So we just found the values of M and N. So the value of M is 0. The reaction is 0 order in A. And the value of N is 1. The reaction is first order in B. Whoops, accidentally erased my A there. So what does that tell you about the rate law? Well, we can figure it out now. We'll just say that the rate is equal to K times the concentration of A to the 0 power times the concentration of B to the first power. Since anything to the 0 power is just 1, the rate is also equal to K times the concentration of B. B to the first power is just B. So that is how you determine the rate law using the method of initial rates for a reaction that has two reactants.